Okay, this is a really pretty easy lecture today, okay? It's not going to require a ton of brain power, but because it's an easy topic, I'm giving you on homework some things that you kind of have to think about a little bit, right? So I thought maybe I'd show you the kinds of things. But first of all, we got to talk about how to do this, writing parallel and perpendicular equations. All right? So if I had an equation, y is equal to 1/3 x plus 10. What is it that makes a line parallel? What would have to always be the same? No.
So,
The slope. Do you agree with that, Aiden?
the fraction.
Yes.
Is that what you're going to say?
Yes.
The fraction, right? That is the slope, right? When you go skiing, right? You know, you might be professional like me and you go to the green slopes, right? The little green dots. No, actually, I'm pretty good, actually, to be honest with you. But
Oh yeah, you
But-
do like backflips and stuff, right?
but no, I don't do that. I used to on a
Oh,
diving
yeah.
board. I was a diver in college. But anyway, that's another thing. That's a whole long time ago. Actually, I'll tell you a really fast story. I can't believe I'm doing this on video,
No,
but I will
just
do it anyway. I will tell you. I went to a small college and I decided to take a springboard diving class. It was just a fun class, right? Well, I was better than everybody else in the class, significantly, right? But that's because I had done a lot of diving because I was a swimmer. I mean, I just liked, But anyways, and so the coach comes to me and says, I want to recruit you for the swim team as a diver. And I'm thinking, I'm hot stuff. Like, oh, this is really cool, right? And I'm thinking, yes! Oh, they see how magnificent I am. Well, it wasn't that I was magnificent at all. It was just that they only had one other diver, and he was magnificent. And he needed somebody to talk to. So I was really being recruited to be somebody for him to talk to, right? I was not good. I was not a good diver, not for that kind of stuff. But anyways, so I dove off the 3 meter, the 1 meter, and the 3 meter. The 3 meter is really up there, right? And so I did stuff. I mean, I did nice dives, 2.5 somersaults and 1.5 with a full twist and lots of different things that are kind of fancy looking.
Yeah.
But I wasn't great. And then I was just looking, I typed in my name in Google a few years ago, and went to my college, and it took me to my college, and it said I was on there, I was one of the record holders for the 3 meter diving board. I mean, I couldn't, what? I was awful, and I couldn't figure this out for the longest time. Then I found out that right after I left, they condemned the pool because it wasn't deep enough. So they never had 3 meter diving after that. And that's why I was professional. That's why I was always on the, oh, Gary had, he was number 6 or whatever. Actually I was number 10, right? I was number 10. It was like I was the 10th.
Wait, how old
best.
were you when
But that was only
when you
because
did it? How old were you?
college, like 18, 19, 20. Something like that.
So much fun diving.
It is. Okay. So anyways, I don't know where that came from. What are we talking
Oh
about?
yeah, from
yeah.
saying that you were a professional snowboarder.
All that came from the slope.
I can't believe this. Okay. Okay. Got it. All right. I don't know where that came from, but so on a slope, right? If you go down the green dots, right? Hopefully the slopes are about the same, right? That they're relatively easy. And then when you go to the blue squares or something, right? Hopefully they're a little bit steeper, but all the blue squares are hopefully going to have the same approximate slope. When you go to the black diamonds, right? The double black diamonds, hopefully they're all straight up and down, right? Right? So the slope. Okay. So the slope is always the same if they're parallel, right? So if it's parallel, I don't know if I'm spelling this right, but hopefully I am. Parallel. Slope is the same. So what would be an example of an equation that is parallel to this line right here? What's an example? Okay, Mark.
Y equals 1/3 x plus 14.
Yes. Okay, I want another example. Okay, Victoria.
Y equals 1/3 x plus 9.
Okay, Molly.
Y equals 1/3 x plus 7.
Right. Okay, anybody else? Weston?
Yeah, sure. Y equals 1/3 x plus 6.
Okay, he said minus 6. I'm sure he said minus 6. Okay, so it doesn't matter. This can be plus or minus. The main thing is that number is the only thing that changes. So, guys, Sabi, look. So that stays the same. That changes, right? And all that does, that means it's down here, right? It just, you're going to start at these different places. Negative 6 is down here, boom. And it's going to be up 1/3, boom. And it's going to be like that. And this one's going to be up here at 9, right? And so it's going to be up 1/3, boom. They're going to be parallel. They don't look very, but they are. You got the idea, right?
Yeah.
Very easy. Okay, now, what if I asked about perpendicular? Perpendicular. Okay, perpendicular. So I'm going to erase these. Perpendicular. Should we do it on the graph and see, or should I just tell you?
Tell us.
I'll just tell you because it'll be faster.
And easier.
All right, the slope, this is the way it's worded usually. The slope is the negative, uh-oh, is this on, am I going off the board? Is the same. I'm going to move this a little bit, then I don't have to worry. Okay, perpendicular slope is the negative reciprocal. Negative reciprocal. You guys writing this down?
Yes.
The slope is the negative reciprocal if it's perpendicular. What would that mean? Give me an equation now that is perpendicular to this line. Okay, Aiden.
Y equals negative 3 over 1 x plus 11.
Yes. I don't have to write it 3 over 1. I could just write negative 3, right? Because that's how you'll often see it. Right? You won't see the over 1 if it's a whole number. Right? So the idea is it's going to be the negative of 1/3 and it's going to be flipped. It's going to be reciprocal. Now, okay, so that is it. These two lines are perpendicular. Okay? What if I gave you this? Y is equal to negative 1/2 x minus 6. Give me a perpendicular line to this. Somebody different. Somebody courageous. Thorn.
Y equals 1 over 2 x minus 3.
Okay, the negative, you're right. Negative becomes positive, right? So it means the sign is always going to change. Does that make sense? That doesn't mean it's always going to be negative. Right? It means it's going to be negative of this, which is negative of a negative is a positive, right? So the signs will always be the opposite sign, so it's positive. And then what's your reciprocal again? What did you say?
3.
Reciprocal of 2, right. So it's going to be positive 2x minus 6. Right? That could be any number. The minus 6 could be minus 6, it could be plus 20, or minus 375.2, or anything else, right? It can be anything. Those two are perpendicular. Perp. They're perp. Okay? So does that make sense? Fist to 5. You getting this? Like, it's pretty easy, right? So good. So like on the homework I said, describe in your own words how you can tell if two equations represent lines that are parallel. Right? So you guys could answer that, right? Describe in your own words how you could tell if two equations represent lines that are parallel. Could you tell that? Could you answer that? What would you say, Maya?
Mara.
Mara, sorry. I just dealt with Amaya. I'm sorry. I was just dealing with Amaya a few minutes ago, before class. Mara, sorry.
Basically like the m, which is the slope. If the slope is the same
Right,
number, then
exactly. Great. So all you have to do is look for that number in front of the x, right? And if it is, now, this is only true though if it's in slope-intercept form. Y equals mx plus b. That's important, right? It's got to be in y equals mx plus b, because that way you know what the slope is. If it's in, well, it could be in point slope form too, because you have the slope from that, but it can't be in standard form. Standard
So it has
form
to
doesn't
involve
tell you the
slope.
slope. It does not tell you the
so
slope.
it has to involve a slope to be right.
Yes, you have to be able to see something you know is the slope in order to know that they're parallel, right? Okay? Okay, but what if I said this? Circle, okay, let me try this. I'm gonna erase this. Let's say I said this. Circle 3 equations that are parallel. And then let me think. What was it again? Oh, yeah. All right. There's 4 equations. Circle 3 equations. Guys, watch this really carefully. I say circle 3 equations that are parallel. It's kind of confusing, don't you think?
Yeah.
All of them are
First of all, are they all in slope-intercept form?
Yep.
Yes.
Are they?
One of them
Which one is not?
Wait.
y.
No.
Wait, Aiden.
The second one, y equals 12.
Yeah, so how should that be written really?
It should be written y equals 4x plus 12.
All right, so let's rewrite it. Y equals 4x plus 12. Okay, is everything else now in slope-intercept form? What? Who said no? Weston.
The last one, the 2y.
Oh, it's supposed to be y
Yeah.
equals, not 2y equals.
Divide everything by 2.
Divide everything by 2. All right, let's try it. What does that give me?
4y.
Who said that?
1y.
Division.
Okay, y is equal to 8 divided by 2 is 4x
Now I got it.
plus 1/2, right? All right, now tell me which equations do I circle?
The first one.
The first
second
one?
and the last one.
The second one and the last one. There we go.
Easy.
But you see how you have to manipulate some of them? You have to have them all in slope-intercept form. Savvy, does that make sense? Thorny, does that make sense? Huh?
Yeah.
It did? Okay, good. All right. Circle 2 equations. Boom, boom. That's that. That's easy. Oh, you're gonna love this homework assignment. It is easy peasy. All right. So that's it for the lecture.
Thanks.